This clip, we're going to look at the Donegal dentist case study, and in particular at the clinic table and the appointment table, and the relationship between them, and what happens when we try to add rows to the child table in this relationship. So in this association between clinic and appointment, we say that a clinic may have many appointments, and an appointment relates to one and only one clinic. So what you'll notice is that the clinic ID column in the clinic table matches the clinic ID column in the appointment table. But if we look at the relationship more closely, we can see that the two columns there, clinic ID in clinic is linked to clinic ID in appointment, but we notice that the referential integrity option isn't ticked. And because that isn't ticked, our relationship between those two tables is very weak. So we're going to examine what happens when we leave that option unticked. In other words, we effectively have no way of tracking what happens when we work between the two tables, when we add rows to one table or delete rows from a table or modify rows in a table. So we'll just cancel this for a moment, leave it as it is, and then we look at the two tables. So the clinic table, as I said, is the parent table, and we have 5 clinics. Clinic 100, 200, 300, 400, and 500. And then in the appointment table, we have 12 rows, and what you'll notice is that the rows here from the clinic ID value, that all of the clinics are involved in some levels. So clinic 100 is involved, 200, 300, 400, and 500. So every clinic has at least one appointment. And we're ignoring the other potential foreign keys here like dent ID and pat ID for the moment, because we're only working on the relationship between clinic and appointment. So those other columns don't really have a role in this exercise. So anyway, the question is, what happens when we try to add a new appointment to the appointment table? And in particular, what happens if we provide an illegal clinic ID? In other words, a clinic ID that isn't one of the 5 clinics that we can see in the clinic table. In other words, it isn't one of those 5 values. So we're on the appointment table, and we're going to put in a new appointment. So we'll put it for patient 100. We'll put it for the 14th of September. We'll make it a filling. Give it dentist number 2. So the fee is going to be €200. The amount paid is going to be €10. The pay method is check. And the clinic ID, we'll say it's 600. So when we click off this row, that will tell Access to kind of finalize the row. So we click anywhere off the row, above it or below it, Access is going to then establish if this row is valid or invalid. So we click here on a different row, we see that the 600 seems to be fine. And the reason Access accepts this value of 600 is because we don't have a strong enough relationship between the clinic table and the appointment table. In other words, we haven't enforced referential integrity. So we now have a row here in the appointment table. This last row is an appointment that doesn't have a proper clinic. That's an illegal appointment in that sense. But because the relationship between the tables is so weak, and in referential integrity isn't enforced, then Access is allowing us to get away with this. So what we've just done here is we've added an orphan row to the appointment table. We've added an appointment to the database that doesn't have a matching clinic. So Access is going to allow us to close the table. It allows us to close the clinic table as well. So there's a row in there that's now illegal. So if we then discover that there's something wrong and we want to actually strengthen this relationship, and we go in and we tick the enforce integrity option, and we OK that, what Access is going to do is, as we hit the OK button here, Access is going to check and see, is this new relationship or this new aspect of the relationship where I enforce referential integrity will be enforced or not. So enforcing referential integrity means that every parent row, every child row should be associated with one of the parent rows. But we know that in the appointment table, we have a row that's linked to or associated with clinic number 600. And the problem is that there's no clinic 600 in the clinic table. So when we try to OK this, access is going to tell me that it can't create the relationship. It can't, it says in the heading there, it can't create the relationship, this relationship, and enforce referential integrity. So what it then says is data in the table called appointment, in other words, the child table, violates referential integrity rules. And in this case, for example, there may be records relating to a clinic in a related table, but no record for the clinic exists in the primary table. So the clinic ID value in the appointment table is illegal, and therefore the constraint or the rule or the relationship with this enforced integrity, referential integrity option cannot be created. So what Access is then suggesting me, it says, is to edit the data. So the records in the primary table exist for all related records. In other words, it's saying that in the child table, every child must have an associated parent row. So the if I want to create, it says a weaker version of the relationship without following the rules of referential integrity, it says I can clear or untick the box again. So I'm going to say agree to that, and I have two choices. I either untick it, or when I go to close it here, Access won't save it. So if I go back in here, the enforced integrity option has been disabled again. So the only way I can rectify this is by going out to the clinic table, and the appointment in question is there at the top. I nearly missed it. It's up the top or near the top. It's there with the value 600 on it. So if I decide that this appointment shouldn't be for clinic 600 and instead it should be for clinic 400, I'm now going to change its value from 600 to 400. And then when I go back into my relationships option, at this stage, every appointment now matches one of the clinics in the clinic table. In other words, all the appointments at this stage are for one of the clinic numbers between 100 and 500, and then they match up with one of the clinics in the clinic table. So if I go back in here again and click on the relationship properly, when it opens up, it again shows me the two table names, clinic and appointment, and the clinic ID matching the clinic ID. And now I can tick the enforce integrity box. When I click the enforce integrity box this time, and I press the OK button, when Access does its check, it needs to check things in the appointment table. But the trouble here is I have the appointment table still open, so it can't do what I want to do while the appointment table is open. So I'm going to have to abandon the exercise again and go back to the options up here, close my appointment table. So now all of my tables are closed, and that's following one of the good tips about Access is unless something needs to be open, keep it closed. So in this case, the finalization of this new relationship or stronger relationship was delayed because I had the appointment table open. And if I now go in again and just simply tick the enforce integrity box, as I said earlier, all of the appointments in the appointment table are now for one of the 5 clinics. They're for either clinic 100, 200, 300, 400, 500. And when I hit the OK button here, Access is going to be fine. It's going to accept that all the values in the appointment table relate to clinics, at least one of the rows in the clinic table. So every child row has a matching parent row, and therefore we're enforcing referential integrity, and there are no orphan rows in the appointment table that violate that referential integrity rule. So that illustrates the importance of the enforce integrity option, the enforce referential integrity option here. It prevents us either adding new rows to a child table that violate the foreign key and therefore don't conform with the relationship, and likewise it can stop us changing rows in the child table that violate that association. So that's the relationship enforced. And the last thing we can do here is we can go back to the clinic table, and we can try and pick, say, clinic 500. So clinic 500 has matching appointments. So the third aspect of trying to demonstrate the benefits of enforced referential integrity is when we go here and we try to delete a row. So we're now trying to delete a parent that has associated child rows. So the clinic we're trying to delete 500. There's at least one appointment relating to it in the appointment table, and access therefore will not allow us break the enforced referential integrity rule. So we cannot abandon that, we cannot delete that row as a consequence. So that's the demonstration of the benefits of enforcing referential integrity in a database when it comes to adding new rows to a child table or trying to remove rows from the parent table. So there's various ways where the benefits of having the enforced referential integrity option enabled in the database, and there's some of the benefits. So that's the end of the clip.